Gautam, wait, I can see your slides, but I can't hear you.
Can you hear me now?
Yes, now we can hear you. Thank you.
Yeah, thank you everyone for joining. And yes, we are going to talk about Big Replicate today, basically a patented active transactional data replication scheme. So years of work has been put up towards this data replication algorithm and technology to be live for Hadoop. So what it does, a quick demonstration on how this technology basically enables everybody to have read and write capabilities almost in sync all over their data centers. So there are some topics that we are going to cover during the talk, and we are going to also represent a demonstration on how we are actually doing it. So basically, first I would walk through the slides that tells about what this data replication is about, and basically uh, getting in depth of how this data replication actually takes place onto a data center. So most of you who don't know about active transactional data replication, it's basically active is when, let's say, there are two data centers, and in one data center you have you perform a write command, and you basically try to, let's say you are creating a directory, and you basically try to create that directory onto other data center. Let's say one data center is in Los Angeles, and another one is in Chicago. And then let's say you are sitting in LA, and you're performing a write a query onto your database at one data center, making a directory, let's say name as test, and then you want to another programmer is sitting on Chicago, and he's trying to create the same directory with the same name. So it would have there's a conflict that the directory cannot be created at one end if it's created at one point. So it's basically active transaction where another user would get a message that you're not able to create the directory since directory has been already created with the same name. So this is when you're performing a read or write across two data centers. So that's basically a little bit of overview on how this technology works. And now going forward, what is Big Replicate? So as I told, it's basically a WANdisco fusion technique. Is the world's only wide area network WAN active transactional replication technology that delivers continuous availability, and you can have a streaming backup. Plus you can do migration of your data from one data center to another depending on network latency, and across all data centers. And then you can use hybrid cloud and burst to cloud depending on the your demands and your company's SLAs. And about the replication engine, it's powered by WANdisco patented technology. So it's basically a technology that has been developed over years by WANdisco, and it's been a part of IBM, and it's an active replication, transactional replication that does guarantee consistency in data, and we can have any number of clusters at any distance. So we can actually connect a lot of data centers and can sync, on all those data centers. Then there is the selective replication you can perform based on, you can have certain data folders onto your one data center, and you want to, let's say, have the replication of those only that selected folders onto another data centers, depending on, you want to save on your storage and different demands, or depending on the criticality of the data that you want to transfer. You can do a selection on the data replication too. And then virtually zero RTO, RPO, we are going to discuss this in detail going forward. And then it's a total non-invasive. That means it's very secure technology. You can turn it on or off based on whenever you want to do data replication, and there is no modification you will be doing at source code. So you basically have the access to just to your data and not to the algorithm. So, and then how it works is basically a proxy server that we deploy on each clusters. So that cluster could be Azure, S3, OpenStack, Swift, IBM, and then Google Cloud. So could be any cluster that you have all across your data centers. And let's say on all the clusters we deploy a proxy server. It's not a master slave architecture. It's basically peer-to-peer connectivity, and it is exposed to HCFS is all the file systems that are compatible with the Hadoop. It is exposed to the API that is HCFS enabled, and then there is a fusion technology through which the applications could connect to HDFS. So what it does is Big Replicate is something that would make all your data centers sound like exactly one large data center. Like the connectivity is basically very strong, and how the data replication take place and what it does is actually we are gonna talk about now. And then it provides a single virtual namespace across clusters, and the distance does not matter. It could be your clusters could be anywhere, and it does break down all the information silos, or network latency is one of the key factors. And let's say there is one cluster and you want to replicate the data among, and there are three clusters, you want to replicate the data among three. It does replicate the active transactions on all three of them. So no matter where what data center you want to perform a query, you can actually do it in real time. You can actually feel the real time synchronization on your data centers. And then it does replicate cloud object storage and your NFS mounted systems, NFS mounted file systems. It's basically a different protocol how your data is transferred over cloud or over network. And then there are certain features of Big Replicate. It's basically 100% uptime. So we kind of tend to say that it's 100%. There are certain cases when let's say there is one network breakdown, or one data center that let's say it breaks down, then and you're transferring some data onto that particular cluster, and let's say there's a 100 GB file and you have only transferred 50 GB yet. So there are chances where that recovery is a little tricky. So we do say it 100% uptime, which is true in most of the cases. So it's basically it would reduce your costs, and you don't have to lock in with one particular vendor. You don't have to go with the IBM or Google or Microsoft. You can particularly use any of the technology in order to have Big Replicate or data replication. And then the complexity is reduced, data is protected, it's just very secure. And we are going to show the different type of authentication schemes, including Kerberos and third-party trust that we use. And then it could be easily deployed on cloud or hybrid cloud. So that's another feature. Benefits we discussed, apart from that, we have continuous availability, and performance is it's basically land speed, read and write, that is provided at all the locations. And it could be installed on top of live clusters, and the downtime would be, if you are manually deploying, it would be just 1 or 2 hours, but not more than that, at the basic installation. And it's, or it's zero downtime. You can even continue working on your clusters live. And then we have support for different distro and multiple versions of the same distributing OS. So it enables migration and upgrades across clusters. So let's say there is an upgrade, then without any downtime, we would be able to perform that upgrade. So let's say there's a newer version of Big Replicate that is announced, then Big Replicate claims that they would, do upgrade without any downtime, which is a very good benefit. And then clusters can be, on-prem or in cloud. So it's not just that, the companies or people who want to have the clusters installed on-prem, they're not able to use. No, they would also be able to use the technology. And then we're able to do full use of resources. We don't, it claims that no money is wasted doing read-only backup clusters, and the multi-data center ingest that we can perform. So you can basically pretty much ingest and analyze data from any location, and that could be concurrent. So it eliminates the risk of moving data. Let's say you have to move data, you don't have to send out those bulky emails and saying it to people that you need to wait for us because we are performing upgrades. So those kind of things are taken care of here. And then you can do selective replication, as I said, and that data protection is one of the other key features of this product. And it's flexible, it's future-proof, it's been upgraded, and a lot of releases have been already launched, and it does get upgrades as when technology is taken to next step. Let's say there's a newer version of Redshift or Big Insights or any other cloud platform or Hadoop application. Then that's when Big Replicate is upgraded too. So it could be deployed on any number of Hadoop distributions. Could be on-prem or cloud or hybrid cloud. And then there's a hybrid cloud and cloud migration. That is one of the other features of Big Replicate. What are the different use cases? Whenever we are talking about, so most of the companies nowadays, what they does is they have a lot of locations, and on all those locations they have a lot of data. All that data needs to be seen by executive level people, sales people, and all the vendors who are actually selling or are in regular touch with clients. We can take example of a retail store. So a retail store that has locations all over the United States, let's say Chicago and New York, and all different places. So they do have data coming in from there. That all that data could be landed to one particular data lake or a data repository, and that could be analyzed in order to generate reports that the number of sales at this particular location has exceeded so and so amount. And let's say if it's a retail company that deals in let's say fashion or clothing, so let's say there is a particular type of shirts, those are sold out and are in demand, so that particular demand can be compensated onto the analyzing in real time that these are the shipments that you need to transfer or ship to this particular location since they are sold out. So those kind of crucial real-time analytics can be drawn out using data lakes. So data lakes is the concept is very clear. It's basically having all the data in one single repository where you can generate dashboards or reports for all level of people. So for executive level, they would know that this shipment is in progress. The vendors would know, yes, they are expecting the delivery at this time and they should be there at the store. And for people who are actually doing the shipping, they would be aware that this is the location they would be picking up the apparels in order to deliver it to that particular location. Whereas at the same time, the manufacturer would also know that they have to produce this much amount of apparel in order to send it out. So that data lake concept is widely accepted by all the companies all across industries. And then as I say, that it's a 360-degree view of global supply chain where you can manage you can have all the level of employees or people who are involved in the business processes to actually define their requirements and to actually gain insights on the product. We can also do trend analysis and predictive analytics, and compliance monitoring based on these data lakes. So it's big replicate comes in play when you have to move that data from that particular vendor to the data lake. Also, when you have to maintain that data, so it's very crucial to maintain that data in order to do these analysis and perform these predictive analytics or do a compliance monitoring, because uh, the more we are having protecting the data, the more we would be streamlining the processes. So there are different requirements that these processes often face, that the data is actually ingesting. So let's say there's a sale of point at one particular location that's in New York, and you are able to buy one product, so that data that this person bought this product associated to your email ID. So whenever you swipe a credit card, that a particular barcode item has been sold to you, that data is actually ingested from one location, and it could be ingested from different locations or sources. So that data ingestion is happening almost during the day at different locations and parallelly, and the number of users are basically performing the transactions in real time and concurrently, so that and then it becomes a responsibility to for having the data consistency and data integration in order to do the real-time analytics, in order to analyze and do a predictive analytics, and also in order to maintain your supply chain management or global supply chain. So with using this technology, there is a 24/7 operation with no downtime and no data loss. So you can actually be very confident in running your business processes. And that's one of the major use cases that Big Replicate has. Another is you can do real-time analytics. As I said, you can actually, you would actually know that this is the point of time. You are able to uh, you know send more items onto your store. So this is just an example, but you can also know the person who's swiping a credit card at your point of sale is basically is not a fraud customer. He's not somebody who's using someone else's credit card based on, and we can actually look at the trends and buying habits and those kind of other analyses, so that the company doesn't face issues from the merchant processor or onto their gateway. So industrial sensor data analysis, you can also do analysis on based on sensors, like let's say it could be let's say if there's a person in a store and he has 5 different type of toothpaste, and he's particularly he's basically looking up at one type and he wants to pick up another type. So what are the probabilities that he's gonna go with what kind of toothpaste he bought? So those kind of buying habits are basically you can analyze them using sensor data. So let's say when you are picking up one particular item and then you are placing it back, so it goes in the system that using the sensors, that this item was removed from the shelf and then it was put back again. So there was a potential buyer and he chose this product over the other product. Why did he choose that? So those kind of analysis you could do using sensor data. That's just an example, but this area is huge. And we need to analyze this using fast streaming. Yes, because let's say there's one particular brand and kept in your store, and that person is basically putting it lifting it up, and that sensor data actually sends that data to you, and then he is placing it back and picking up another thing. So as a company, you can always make sure, in order to send some kind of deal onto as a message onto his cell phone, saying that you get 5% off if you buy this product. There are chances then when that particular user would want to buy that product because he just got a message that he is getting 5% off. So those kind of real-time offers or promotions you can perform using real-time analytics. So that's another thing. And then hybrid and cloud migration, there's this storage that comes in place all the time, because it's a lot of money in order to store this data. And as we speak in the slide, cost containment and offsite disaster recovery is one of the other important features. So it basically what it does, it unifies all on-prem or cloud clusters, gives you one single data repository view. So that ways you are not missing out on any particular data, and none of your members in that business chain is not getting a blockage from the view that they're supposed to. So what are the common replication techniques? Why is Big Replicate better than, why it's the world's only WAN technology that is able to perform data replication? So multi-data center Hadoop today, we are doing periodic synchronization or parallel data ingest. So there are techniques that are in place. There are connectivities that provide the data migration. There are shell scripts that you can write in order to do the data transfer. But then Big Replicate is something that defines it uniquely. This being you can say that nowadays that in data center Hadoop, big data centers, you can run jobs using MapReduce. You can write your shell scripts. You can write a Java code in order to perform migration. You can use other techniques in order to. There are some queries that you can write in order to move particular data, but that's some task that you have to perform, because the key challenges that you face are the frequency of the data. It's the kind of loads that you're doing. Is it an incremental load? Is it like a full-time load? It's full-time data ingest. It's something that is completely dependent and demanded by the business. So Big Replicate it takes in consideration all those points and do perform communication. How does we do that? We would quickly move up to the slides where how we do the data transfer. There are certain other points where we say that we move data, why we do it: for backup, for disaster recovery, for computer restraints, and for high availability. But then because just to give an idea, we would go to the technical overview. Yeah. So this is the patented DCON-E technology that enables active replication. So with guaranteed data consistency over clusters, using LAN or WAN, both. And as I already discussed, that it is all about there's no vendor lock-in. You can use MapR, one of the other cloud or cluster provider, and then you can use ENC Isilon or Amazon S3 or Microsoft Azure or Google Cloud Storage or IBM, or whichever technique you want to use. There's no vendor lock-in for it. And then there are software development kits that are available on GitHub and also several other places. You can always we can always share those kind of resources with everyone. And then there is a continuous availability and disaster recovery that is provided over WAN. So that's what I said. I've been telling from the presentation that all the clusters and all the locations, they give a unified view. They appear, act, and operate as a single cluster. So you are not missing out on any data across any location. And there are no failure points that you would, and we have taken consideration that based on enhanced Paxos algorithm. So Paxos algorithm is basically the algorithm behind writing this framework. So we've been analyzing this from quite some time now. How would be the experience at LAN, at WAN distance? So there are certain technical points where we need to be a little cautious while transferring the data. So what they are, we would discuss it now. Before that, we have the architecture principle. So there's a synchronous replication, there's a asynchronous replication. It's basically, active-active, or it could be active-passive too. So when I say active or active-passive, I mean that with active-active, it's read and write both, and with active-passive, it's read and write plus read. So there are certain times when a particular cluster goes, it breaks down, or it goes into a safe mode where it's just performing a read. So that safe mode is basically a passive, and it would come back whenever there is a recovery, and then all the data is always synchronized to it. So that's another feature. How the Connie works. So there's a majority quorum. Let's skip to another slide that would showcase it more easily. So yeah, over here. So we have A, B, and C as 3 clusters. As we see, we have HCFS, Hadoop Compatible File Systems, HDFS, Hadoop Distributed File System, S3, and MapR, or it could be any other cluster provider. So what happens is, there's this user. This one user is trying to write a file or construct a file on A. So A is basically coded by a Fusion server. So Fusion server has the Paxos algorithm. So how it works is, whenever a user wants to perform a write on A is basically using Fusion server. He wants to perform a write onto his cluster. So he would send a write request, and then there's this proposal that is sent to other 2 Fusion services. Those are coordinating with the clusters. So as you might see, there's this user who wanted to perform a write. When he sent out that command, there is a proposal that is sent out to B and simultaneously to C. So once he has sent out the proposal, there is agreement that has been sent out from B and C to A. So what it does is basically acknowledgement that whenever he's trying to make a directory on A with the name test, and at the same time some other user at B is trying to perform the same write saying test, this is an acknowledgement from B and C that test has been already created in A. So that ways we are able to perform this active-active replication. So this is the underlying thing that defines how it works. And then after that proposal and agreement, that write is performed on cluster A. And then it is, it's communicated to B and C. So that's how the active-active replication is maintained. It's very convenient to understand using this diagram that how the technology is basically performing the replication. So quickly moving to the demo. Since we have 30 minutes left, I would definitely want to share the live version of Big Replicate. So this is something that we have. I would hand it over in order to look at how the technology actually works. So we basically have a demographic area. This is a dashboard of WANdisco Fusion, and I'm not sure if the audio is.
That has been replicated.
Yeah.
On this dashboard interface, we can see the location of our 2 clusters. I have a cluster in California and one in Virginia. Each of these clusters is running 2 Big Replicate servers. This is why I have 4 tabs open. Each one represents an individual dashboard interface, just like the one we're looking at here in this region and zone called West 1. If I scroll down, I can see a list of all the activity that's been performed in the recent hour. And I can also see the volume of data that's been replicated recently, which could be impactful for my license, which currently has an 11 terabyte limit. If I keep scrolling down, I can see the Java heap consumption at each of these Big Replicate servers. So I can look at the health of the server themselves, and if something like memory or disk space or CPU looks like it's reaching into those critical categories, I can get email notification on that, as well as things like when the node goes offline, and I can take the appropriate actions, such as increasing memory or adding more CPUs. So additionally in this interface, we have a way to look at the individual servers. We can pull up details, we can view logs, we can see what is included as far as plugins on each of these nodes, and see IP address and other information such as that. The real area of interest in this interface is the Replication tab, and here we see all the directories that we want to use for replication. Now, replication is an opt-in process with Big Replicate. That means you have to define the directories that you want to use for replication. These are active peers, all these nodes, all 4 of them, which means they're all read-write nodes at the same time, but only one server at each cluster location will write to the path at a given time. We call this the writer node. Here you can see I have what we call a consistency report that will show me the differences between the 2 clusters. I can run this report at any time, or I can schedule that to run at automated times and even email a report when the clusters go inconsistent. Now, the consistency report will only display the results on the writer node. So the first 2 directories I have listed here are the writer node of West 1, and the other 2 are the writer node is at West 2. So I would have to go to that node to see the results. So let's do that. I'm going to go over to my West 2 node. You can see the information here is fairly redundant. It shows some of the high availability capability of the Big Replicate server. So if one goes offline, the other one's able to continue functioning. And I can pull up my inconsistency report for this user and bar AQA directory. Now, the consistency report is a very important feature in Big Replicate. It shows us the differences between the 2 clusters, yes, but it also allows us to resolve those differences. So the type of differences you'll see here are missing files, things like metadata inconsistency. So, for example, here the username is HDFS in cluster 1, it's Hive in cluster 2, and group and ACL permission will also be included in this diff report. Now, I can resolve these file by file. So if I go to the first file, the per boot file, I can tell cluster 2 to copy to cluster 1 by selecting cluster 2 as the source of truth. I can also delete the file on cluster 2 by selecting cluster 1 as the source of truth. And if I want to resolve all these changes recursively, I can go to this Repair tab, select cluster 1 as the source of truth, choose to do a recursive or repair the whole folder option, and select this repair button. That will go and queue up a repair operation, which will copy all the files that are missing from cluster 1 to cluster 2. And because I chose not to preserve any files, it will automatically delete or clean up any additional or extra files on cluster 2. In essence, what I'm doing with this operation is making the 2 directories on the 2 clusters match one another. And then I can go back to this consistency tab and wait for the report to load. And once it does, I can click this recheck button to queue up a new consistency check on that directory, which you can see is now showing up as consistent, which is what you would expect after you execute the consistency check. Now, this is a solution that is a very point and click. So I can click this create button here and walk you through the process of adding a new replication folder. I can browse the HDFS directory tree. If I click on the folder icon, I can expand the directories themselves and see what all the subdirectories are. And then I click on the name itself to add the directory that I want to replicate. So I'm going to add this REPL3 folder. I'm going to select the zones that I have. I only have 2 clusters right now, so 2 zones. But if you have 3 or 4 or 5, such as testing or dev or multiple production or disaster recovery sites or even a cloud site, you'd be able to define customized replication patterns for each of those. I'm going to skip any advanced options and go ahead and just create that directory. I can then do a consistency check on this folder once the writer has been assigned. Again, the writer assignment is so that only one of these servers is writing to a directory at any given time. If that server goes offline, a new writer gets elected. So in other words, if West 2 is the writer and he goes offline, someone tries to do a write, West 1 gets elected the new writer, he begins to write. That way you don't have any loss of replication operations during any production usage. So I'm going to go over to West 1, which is the writer, and pull up my consistency report. Here you can see I have a bunch of files that exist on the left side, cluster 1, that aren't on the right side of cluster 2. Now, when you're adding Big Replicate into an environment for the first time or doing the migration, this is going to be pretty common. You may have a bunch of data on your production cluster, but none in the DR cluster. We would use this feature to move all the data to the disaster recovery site, or if you're doing a migration, for example, from an older version of Big Insights to a newer version of Big Insights, or maybe you're moving from Cloudera and Hortonworks to Big Insights, you'd be able to use this feature to move the data from the old cluster to the new cluster. Now, while that's running, that repair operation, there was quite a good size of data. We can actually see the data in flight. So one of the neat things that Big Replicate can do is show you incoming transactions. So while that data is moving from cluster 1 to cluster 2, I can actually watch it. I can see how fast it's moving. I can see the time it started. I can see the time it completes. And in this way, I can monitor the health of my network as far as the replication is concerned. And I can also see an audit of recently replicated data, and maybe even get an idea for when my 5 GB file will complete replicating across the WAN. Now, this is an active-active solution, so I want to queue up a nice little active-active scenario just to show you that the Big Replicate server can be used to perform many different tasks at the same time. Now, in this scenario where I'm moving all the large chunks of data from cluster 1 to cluster 2, this might represent some type of migration. But while you're doing the migration on a production cluster, you may have new data that's incoming all the time. And because we're active-active, I can generate new data in both clusters. So what I'm going to do is use Teragen, which is a benchmarking tool in Hadoop, to generate a new 12 GB data set in each cluster. And while that runs, once again, I will be able to see the data arrive as it's being generated. Now, another neat thing that we do with Big Replicate is that we can send data into the WAN cluster, the remote cluster, in this case the DR site, cluster 2, while the files are being generated. So before this MapReduce job even finishes, while it's still running, once it gets to the reduce phase, it'll start writing data. We will be able to see that, that those files are incoming into our cluster before the MapReduce job is even finished. And what this means is that Big Replicate will be able to provide the best possible RPO. And RPO in this case means the ability to reduce the amount of data loss, recovery point objective, to the absolute minimum. And we can make that claim because we can actually transfer the data in the HDFS cluster before it's fully written to the cluster itself by grabbing the first block available and sending it to the remote cluster. And with other solutions, other copy solutions, you would have to at least wait for the files to be generated before you can move them, and we have no such hang-up with Big Replicate. And here we can see that transfer has started, that the data is still in the Teragen temporary directory, so the final files haven't been created yet, and already the data is transferred. So this is a great feature that Big Replicate offers. Not only is it active-active, not only can you do migrations while you're doing data transfers for new production data, we can send the data even before it fully lands in the cluster. So, this is to demonstrate a number of things with Big Replicate. One is the ability to actively move data. 2 is to show how we can transfer jobs such as MapReduce jobs, and this can be applied to things like Hive and other applications, HBase, anything running in the cluster. And the important thing to note here is that Big Replicate does not run as part of a MapReduce job itself, or it does not use Yarn. It is its own replication engine. So data replication is occurring from Fusion node to Fusion node. That's the purpose of those writers. And this means that we are not interfering with the production performance of your cluster. So you can run this thing continuously all day long and really even out the performance of the network, which would typically be using large times scheduled batch-based copies that would clobber your networks typically. But with the Big Replicate system, not true. We're doing continuous data replication. You can still see the activity chart moving down here. And that allows you to have a much more smoother impact on the network over a longer duration and The fact that we don't have any impact on a production cluster means that you can run this continuously and thereby achieve much better SLAs through RPO and RTO. Thank you for watching this demonstration.
So coming back to the RPO and RTO, as a Big Replicate delivers local network speed, read and write access to the same data across every location, could be on-prem or in cloud at any distance. There are built-in continuous hot backups that with automated recovery that delivers the lowest possible RTO. RTO is the recovery time objective, and RPO stands for recovery point objective. So that means that the demands of the business are met the most, and including the regulatory requirements. So there are reduced costs and several other factors with simplified backup and recovery, migration and expansion, and also migrating to cloud and going hybrid with absolutely no problem and zero downtime. So this is mostly the overview of Big Replicate that we were demonstrating over here. It's the one of the finest technology, and one of the key features that helps attain one of the most discussed objective of data migration and data transfer. With IBM Big Replicate, it makes it possible for the first time ever to migrate production data into the cloud and without downtime or data loss. And once we have migrated, it becomes very easy to go hybrid and move data in and out of the cloud as it changes, or the changes could be incrementally or one-time load, or on demand, or burst out processing, and or offsite data replication too. And it's basically works as the data streams in. So it's files do not have to be like fully written and closed before transferring the data. One other thing that we mentioned over here about Big Replicate is it's let's say there are times when one data center, let's say A, it's asteroid hits it and it's not in use, and it goes back into a safe zone where in that safe zone what happens is B and C are working as the active peers, and the decision that what would be the name of that particular file or what write command to execute would be based on the majority quorum, and at that point of time when B and C are the only one that are alive, so it works as peers, not as master slaves. So they both have the capability of deciding on performing a write, and when A comes back up, that is the time when B and C can synchronize all the data to A. And that's how the data synchronization and data failure or data recovery is possible. And then it's non-invasive technology. It runs as a client application and could be managed using CM or Ambari. So for Ambari, we actually have IP addresses that we can demonstrate based on we can actually look all the technologies. Those are we can these are the technologies that that is from a cluster where you have HDFS, MapReduce, or all other clusters running, and you can actually have this WANdisco fusion service and taking care of the data replication, and it could be at any cluster provider or Hadoop service provider. So, and IBM Big Replicate replication is basically it's again a distributed coordination. It's not a master-slave architecture. It's when all Big Replicate server functions as peers to deliver the same transaction order at every site, as I mentioned, and also based on WANdisco's patented enhanced specs algorithm, and it gives you a LAN experience even at a wide area network distance. So you feel like you're removing the network silos, and you are working in synchronization in real time. opportunity and endpoints. There are new opportunities, new customers for, there are points when people want to opt for big insights. Big Replicate is a real value add-on that comes with it, and it could be on-prem or cloud. It could on cloud, it could be on Bluemix or software layer or with Spark. On-prem, it could be with customers who are in production and who are ready to add a disaster recovery process, or on secondary clusters that are into QA or development environment, those requiring real-time analysis or analytic clusters. It's really unique because it is consistent across and guarantees consistency between the source and the target clusters, and you could even select the particular folders. The user interface is basically drag and drop and click, so it's very easy, and you can even see what are the files that are transferred, even with the file size and transfer duration. And then if we can perform consistency check, visually analyzing the inconsistencies and making decisions, if you want to have the data or no, or if you want to turn off or on the feature. So that is another thing. And then we have other opportunities where we can utilize or sell Big Replicate, or talk about environments. So these are strategies or plans that comes in handy, good for customers who are opting a disaster recovery, who are offered Spark as service, and who allows you to basically have a timestamps or footprint on your data centers. It supports active or transactional synchronization between multiple Hadoop vendors, and comes with the big insights upgrades of version 3x and 4x in a new environment, and migration from existing Hadoop clusters to big insights. It could do that, or vice versa, like Cloudera, Hortonworks, MapR, or S3. You can do the migration from there, and it maintains consistency to the same folders in both directions. So when we say both direction, it means the source and target, and it's basically you targeting the target directory, and then you are performing any other updates on the target directory. The same would be replicated onto your source too. So it protects you in an event when you want to be back to your originating cluster. That's something which we could also say roll back another snapshot feature is much more advanced than that. So the rollback is basically when you have a point where you are actually making a network image or a data image of your cluster, and you're setting up it as a checkpoint, and then going forward, after a month of work, you decide coming back to that particular point when your data was in a safe mode, or when you had a backup. So that's basically rolling back your cluster to that particular point based on a footprint or a stamp. So there are probabilities when you might have a data loss, and those probabilities are, let's say, when you are actually moving a file onto one cluster and the cluster goes down, and at the same time there are network, you are in the process of transferring a particular file to cluster A. So let's say the file size is 25 gig and you have transferred 12 gig of file to cluster A, and cluster A goes down. This is the time when it's gaining proposals and agreements, and it's transferring data. So it might have transferred data to B and C, which would be just 5 or 10 gigs, but not complete 25 gig. So at that point of time, if your A is recovered, then your data could be recovered. But if due to some reason your A fails and it never comes back, and there are chances that you might lose those 25 gig of data, but you can always recover the data that is transferred to B or C. But that is just specific to network latency. It's the type of speed you are getting onto your network. So which is also something that you can boost using other technologies. So let's say when we talk about network latency, let's say there is a point when A is transferring data to B, which would be faster than A is transferring data to C. So that is another scenario that the network data transfer is faster to one cluster than another. So there might be a chance when you have 7 gig of data in B and 5 gig of data in C. So, but that is at a particular time, and it's a very rare case. So existing competitive Hadoop distributions, there are different distributions. There are like on-prem cloud, hybrid cloud, and then there are transformation and migration phases. What are the advantages? When you add edge nodes, addition of big replicate edge nodes to the current environment. So that's like a very minute change you'll have to do. And then there are different transition phase that are standards from this technology, and it also is a short-term disruption to Hadoop users. So it's also a competitive distribution. So this is another advantage. And the drawbacks is like there are not the architectural changes that are happening right now, and it's a bring your own license model. It requires a dedicated failover environment, and it's a managed service. It needs a little support to the cluster with additional cost. And then we already walked everyone through the demo. This is the time when I would invite our audiences to ask questions or clear their queries if they have some.
Adam, there's already some questions that have been asked.
Yeah.
The first one is, what happens with the latency problems?
Yeah. So with latency is, there are tools like Spear that helps network latency boost up. But then, as I described, let's say you have 3 clusters, A, B, and C, and you are transferring your data from one user database to cluster A, and during that particular transfer, when you have transferred 50 gig of data, and you are in process of doing that, let's say there's a failover. That's the point when the recovery is not possible if it's a total failover of A and the transfer is not complete. But apart from that, which is a very rare case, apart from that, network latency is not is something that we have addressed here, or that Big Replicate has addressed here. So from when you're transferring data to A, and simultaneously A is gaining agreement with B and C, sending out the proposal and gaining agreement, and that's while you're transferring the data to A, that data is also transferred to cluster B and cluster C. So it is active that time, so based on that network latency capacity, and which could also be enhanced using a tool called Spear. So that's the answer for that.
Okay, the next one is, why doesn't the UI retain the full path in the data replication rule?
So it's a custom defined path that you can define in your configurations. So it would definitely gets replicated onto different sites, different clusters. So it whenever you define your configuration file or first implementation of Big Replicate, it would definitely take the path that is associated to it, and that is what is shown and considered.
Okay, and the last question is, does this tie into Atlas or Ranger?
So Atlas and Ranger is basically, those are part of orchestration tool. So this is one complete independent thing, but I can definitely show the services that it's tied up to. Let me just try to. So there are these open source services that it could tie to. So these are public IPs that are available. So it's basically so the support is as you could see on my screen, you can actually tie up to your Hadoop cluster, and there are settings you can do and have all your orchestration tools associated to it. So it would basically be connected to your Hadoop cluster, and your if you have HTTP authentication or Kerberos authentication on your ranger. So it's basically how you set up your configuration. So that is at the time of implementation that happens. So yes, I mean, the answer would be yes, it could tie it up to ranger.
Do we have any other questions from the audience? Well, thank you so much for joining us. I would like to remind you that there's a handout that you can download from the GoToWebinar control panel, and it has information about future webinars that you may be interested in.
Also, if there are some other questions regarding Big Replicate, you can always tweet me the questions, and I would love to get back to my Twitter handle is Sivaj Gautam, so you can always provide comments and feedback there. So yeah.
Thank you so much, and thank you everyone for joining us.
Thank you, Anna. Thank you, everyone.